Hello everyone. In this lecture today we are going to discuss about E-type MOSFET. So as we discussed in our first chapter that MOSFET is divided into two parts. Number one, D-MOSFET, that means depletion MOSFET, and number two, E-MOSFET, that means enhancement MOSFET. Well, D-MOSFET we have seen in our previous lecture. Now today we are going to discuss about E-MOSFET, which is called as enhancement MOSFET. So here we can see MOSFET, its full form is metal oxide semiconductor field effect transistor. So E-MOSFET, that means it is enhancement MOSFET. Here we can see these are the type of MOSFET. Depletion type, it is normally known as device is switch off. Here you can see it is device off. That means it is normally closed switch. It is also known as normally closed switch. Whereas in enhancement type, it is known as device on. That means it is normally open switch. So these are the difference between the enhancement type and depletion type MOSFET. So in today's lecture we are going to discuss about only this enhancement type MOSFET. That means it is normally open switch. So it is also divided into two parts. Number one, N channel E-MOSFET, and number two, P channel E-MOSFET. So today we are going to discuss about only N channel E-MOSFET. So let us discuss about the symbol. Here we can see these are the symbol of E-MOSFET. Now it is first N channel E-MOSFET, and here we can see this is the P channel E-MOSFET. Now compare with the D-MOSFET. In D-MOSFET, we have seen that the line is in symbol, in circle, that line is straight. Whereas here in E-MOSFET, it is dash line. So there is a difference between the E-MOSFET and D-MOSFET. Now here this line represents that there is no channel present in the construction. So this is the difference between E and E-MOSFET. So here we can see remaining things are same, that arrows goes inside, that means N channel, and arrows come outside, that means it is E channel E-MOSFET. Now similar for terminal device in construction, source that for S, gate that means G, and drain that means D, and along the substrate, or we can say body, B terminals are there. MOSFET body is basically connected to the source terminal. So we can see in symbol, center line is connected to the source terminal, which is indicated that substrate and source is connected together in construction, as well as in symbol we can see here. So this is the symbol of E channel MOSFET. So this is the symbol of E-MOSFET for N channel and P channel. Now discuss about construction. Here we can see this is the construction of N channel E-MOSFET. Now this is the difference only between the E-MOSFET and D-MOSFET. Here we can see there is no channel present between the drain terminal and source terminal. So this is the main difference of E-MOSFET. Now here remaining things are same as it is we have seen in depletion MOSFET, that metallic contacts are there, drain, gate and source terminal. Drain and source is directly connected to the region of N type, whereas here we can see this is the gate which is not connected directly with channel. Now there is a one layer which is known as silicon dioxide layer, SiO2 layer. Now we provide input voltage between the gate terminal and source terminal. So due to this, VGS is known as input supply. If we apply input here, then due to this input there is a field generated at the gate terminal and due to this field there are attraction of electrons and holes, and that's why current is flowing through that channel. So this is the basic working principle. This is the basic working principle of E-MOSFET. Now here you can see this is the construction. Now this is also construction with biasing technique. For biasing we have to connect two batteries in this construction. Here we can see this side it is VDS, drain to source voltage is connected, and there we can see VGS, gate to source voltage is connected. So this is the connection, or we can say biasing. Now here we are going to conclude these three cases, and after the three cases we plot one graph which is known as characteristics. Also it is known as drain characteristics and output characteristics along with transfer characteristics. So that three cases are here. Case number 1, VGS is equal to 0. First we are not going to connect the battery at the gate to source terminal. That means shorted. So it becomes VGS is equal to 0. Then case number 2, here we are applying VGS is greater than 0. That means we connect more and more positives applied. So VGS is greater than 0. Then last case is increase VDS with constant VGS. So we put constant VGS and we are focusing only VDS terminal. So that means we increase VDS terminal with constant VGS. So these are the three different cases. So we are going to discuss about first case number 1. So VGS is equal to 0, that means it is shorted. If there is no VGS, if there is no input voltage, that means no current flow in this channel. Why? Because here we can see input voltage is 0, and in this construction we have seen that there is no channel present. If there is no channel present, that means drain to source is not connected. So that means here if we apply VDS, even though we cannot get ID, because here we can see there is no channel present between the drain and source terminal. So if we apply VGS is equal to 0, at this time your ID is equal to 0. So this is totally inverse of previous one. So we have seen that first if your VGS is equal to 0, at this time your ID is maximum. We have seen that in D-MOSFET, but here in E-MOSFET it is reverse. If you apply VGS is equal to 0, that means your drain current ID is equal to also 0. So this is your case number 1. Now let us discuss about case number 2. If you apply VGS is greater than 0, so we are going to connect here in this gate to source terminal one positive supply. That's why here we can see first terminal is positive, which is connected to the gate terminal, and negative polarity is connected to the source terminal. Now if we apply positive terminal first at gate terminal, due to this positive terminal, here we can see in construction there is P-type material, P substrate we can say. So there are majority carrier charges are holes, and there are also minority carrier charges which are electrons. So number of electrons get attracted towards this positive polarity. That means if we increase VGS more and more positive side, so number of majority carrier charges attracted towards this side. So due to this, there is one generation of channel. So here we can see in this figure there is a generation of channel in between drain to source region. So we have discussed that first there is no channel present in E-MOSFET, but when we apply here VGS more and more positive side, At this time, we can see here channel is generated. So due to this channel, we can say it is induction of channel, and through this channel current flows from source to drain. So now in this creation, we can say ID flows from source to drain. So this is the case number 2. Now let us discuss about case number 3. Now case number 3, here we can see this is the construction. VGS is increased beyond the threshold level. The density of free carriers in the induced channel will increase, resulting in increased level of drain current. As we discussed earlier, if there is a channel and we increase more and more positive voltage, so number of electrons can attract it. So due to this, drain current flows higher, flows increase. However, if hold VGS constant, now this is the case number 3. If we hold VGS constant and increase the level of VDS, here we can see if we increase VDS with constant VGS, the drain current will eventually reach a saturation level as occurred for the JFET and depletion type MOSFET. So here the leveling of ID is due to a pinching off. Here we can see this channel is going to be decreased, and that phenomena is known as pinch off voltage, or we can say it is beginning of pinch off. Why pinch off is generated here? We can see as we increase VDS, at this time your depletion region, here we can see depletion region is generated in between the N channel and P channel, and here we can see number of electrons are beginning to decrease. That's why here channel is reduced. So we can see in this figure diagram. So this is the drain current which is going to be decreased. So here we can see these are the 3 different cases. VGS is equal to 0. At this time what happens? Our drain current will be 0. If we increase VGS in positive side, so what happens at this time? In positive side drain current is enhanced. That's why it is known as enhanced type MOSFET. By positive gate voltage, the voltage of VGS at which conduction begins is called as threshold voltage. That's why it is also known as VTH, because we increase VGS more and more positive side. That's why it is known as threshold voltage VTH. So this is the working principle of N-channel E-MOSFET. And after these cases, case 1, case 2 and case 3, we can plot here drain characteristics, or we can say output characteristics of it. And from output characteristics, we can plot easily transfer characteristics. We can see that. So this is first output characteristics. Here we can see on x-axis that is a VDS voltage, and at y-axis we can see here this is ID. So if we increase VGS, so here we can see VGS is equal to 1, 2, 3, 4 and so on. At this time your flow of drain current is also increased. So here you can see at first VGS is equal to 0. At this time your ID is equal to 0. This is your case number 1. Now in case number 2, if we increase more and more positive VGS, then your ID also increase. Here we can see VGS 1, VGS 2, VGS 3, VGS 4 and so on. So here we can see in characteristics there are 3 different types of region. First, which is linear, it is known as ohmic region because it is according to Ohm's law. So that's why it is known as ohmic region. And after this, here we can see it is known as saturation region, and below when your current is 0 and voltage also 0, at this region we can say is cutoff region. So these are the three regions of this output characteristics, and from this output characteristics we can plot transfer characteristics. It is the graph versus VGS versus ID. Remember this thing, don't get confused between output characteristics X and Y plot and transfer characteristics X and Y plot. Here in output characteristics we plot VDS on X axis, whereas in transfer characteristics there is VGS on X axis. So this is the difference between the two characteristics. So if we increase here VGS gradually, your current ID is also increased, which we can see here in transfer characteristics. So this is the characteristics of N-channel E-MOSFET. That's it for today's lecture. If you have any query related to this topic, you can mail me on this email address. Till then, keep reading, keep learning. See you soon in next coming lecture. Thank you.